Dear R, today we're going to discuss about weak effects of weak crystal fields on terms. The main theme of this topic is how the terms will behave in particular weak crystal fields. That is, in octahedral field and tetrahedral field, how the terms further going into splits into different energy levels. So, for example, if we take the S term, S orbital and S term having the similarities. So, as we know the S orbital, the azimuthal quantum number for S orbital L will be 0. So that the degeneracy of the term 2L plus 1, degeneracy of the orbital 2L plus 1 will be 1. That is, the S orbital is singly degenerate. In octahedral field, the energy level of S orbital will be designated as A1G, and in tetrahedral field, it can be designated as A1. Coming to S term. For S term, the L value, total orbital angular momentum value will be 0. So the term degeneracy 2L plus 1 will be 1. That is, the S term is singly degenerate. In octahedral field, it can be designated as A1G, capital A1G. And in tetrahedral field, it can be designated as capital A1. So let us now discuss about p term. Same, p orbital and p term will have the similarities. For p orbital, azimuthal quantum number small l value is 1, right? So the degeneracy 2l plus 1 will be 3. That is triply degenerate. It cannot be split into different energy levels. Triply degenerates as it stays only one orbital. So in octahedral field, it can be designated as T1G, small t1g. In tetrahedral field, it can be designated as T1. Whereas for P term, the total angular momentum, total orbital angular momentum capital L is 1 and degeneracy of this P term is 3. And it is triply degenerate. It cannot split into further energy levels. It remains as only single energy level. In octahedral field, it can be designated as capital T1G. In tetrahedral field, it can be designated as capital T1. So let us now discuss about D term. Same, d orbital and d term will have the similarities. For d orbital, azimuthal quantum number L value, small l value is 2 and the degeneracy 2l plus 1 will be 5. Degeneracy is 5 d orbitals, right? And these 5d orbital subshells will split into different energy levels in octahedral field. In octahedral field, the lower energy level is designated as small t2g and the higher energy level will be designated as small eg. Where in tetrahedral field, the lower energy level designated as small e and higher energy level will be designated as small t2. Where coming for d term, the total angular momentum, total orbital angular momentum value, that is capital L, is 2 and degeneracy is 2l plus 1, that is 5. And in octahedral field, it can be further splits into two energy levels. In octahedral crystal field, the lower energy level can be designated as capital T2G and higher energy level can be designated as capital EG. Whereas in tetrahedral field, this D term will splits into lower energy level as capital E and higher energy level as capital T2. So coming for F term, this F term in octahedral field, it will splits into three energy levels. The lower energy level T1G and next energy level T2G and the higher energy level A2G. And whereas in tetrahedral field, the reverse splitting will be happen in tetrahedral field, right? So the lower energy level is A2 and the next energy level T2 and the higher energy level will be T1. Coming for G term, this G term will give 4 energy levels, whereas in octahedral field, the lower energy level T1G and the next T2G and next EG and A1G. Whereas T1G, T2G are triply degenerate, EG is doubly degenerate and A1G is singly degenerate, as we know, right? And in tetrahedral field, it is completely reverse splitting takes place, right? So the A1 will be the lower energy level, next E, and the next one T2, and the higher energy level will be the T1. For H term, so H term also gives the four energy levels, four states. Term will split into states, right? So these energy levels can be called as states. So lower energy level T1, again T1, T2 and E for octahedral, and in tetrahedral the reverse splitting will take place E, T2, T1 and T1. So here one point to be noted that as we go to the terms with higher L values, their splitting patterns becomes complicated and their importance in the binding diminishes in the order. The fact that they do not occur as ground term, right, and they occurs in excited states only. Therefore, the energy levels become will be complicated. Thank you.